Okay, now I shall introduce to you the technique of trigonometric substitution to evaluate integrals. And if you take a look at this integral here, that's going to be pretty tricky to figure out unless we use this method. So if you try substitution or whatever you know thus far, it will be pretty tricky to figure it out. So we have this alternative method that will initially seem a bit bizarre, but I'll just ask you to take a good look at it, pay attention, and hopefully it will make great sense to you. And of course, then later you can practice many times and you will become a master of it. So, oh, that's a terrible looking triangle. Can I draw straight lines? Well, this is a little bit better, I guess. So here's what I'm going to do. We have x squared over the square root of 1 minus x squared. And this here, the square root of 1 minus x squared, makes me think of Pythagoras. And why is that? Because now this is what may seem a bit bizarre at first, but if I throw in an x over here, so this side of the triangle measures x, and if the hypotenuse measures 1, if I use Pythagoras to find the third side, it's actually going to work out to be 1 minus x squared. Okay, because let's say, let's make it a question mark. So question mark squared plus x squared equals 1. So question mark squared equals 1 minus x squared. Root both sides, so question mark equals the root of 1 minus x squared. All right? So, and how is this gonna help us? You'll see. Right now, what I will do is say that, well, if I made this angle theta here, okay? And I'm gonna say that the sine of theta is equal to the opposite over the hypotenuse. So the sine of theta is just equal to x. And I'm gonna work a substitution here. So I will need to derive the sine of theta. So I have the cosine of theta d theta equals dx. Don't forget the differentials, right? So cos theta d theta is equal to dx. So I can actually already replace the dx over here for cos theta d theta. Now all over x squared times the square root of 1 minus x squared. And this is where a bunch of elements from the triangle are going to come into play. So I have an x squared here. What can I do with it? Well, I know that the sine of theta is equal to x. So if I square both sides, it follows that x squared is equal to sine squared of theta. So I'll write that down. Sine squared theta. And then finally we have this weird element here, which we were concerned with right at the beginning, the square root of 1 minus x squared. And when can I do with that? Well, here's what I'm going to do. If I take the cosine of theta, you'll see that we're going to get exactly that, the square root of 1 minus x squared over 1, right? Because cosine is adjacent over hypotenuse. So look at that. I can just actually plug cosine of theta right in there because the square root of 1 minus x squared works out to be the cosine of theta. So at this point I can actually cancel out the cos on the top and on the bottom here, and we're left with the integral of basically 1 over sine squared theta, and that is just equivalent to the cosecant squared of theta. Correct? Of course. So now, do you recall what the integral of cosecant squared is? It's actually just the negative cotangent of theta. And we need to add a constant c to this, and that is the answer, but not the final answer, because we want the answer in terms of x, not in terms of theta. And how can we do that? Well, what is the cotangent of theta considering this little triangle here? Well, I got theta here. And remember that cotangent is going to be the adjacent over the opposite. So remember, because it's just basically the reciprocal of tangent, right? I'm assuming, of course, that all you guys are comfortable with your trigonometry. And so we have negative cotangent of theta, so that's going to be the square root of 1 minus x squared, because that's the adjacent over the opposite, plus c. And now this is the final answer. That's it. Of course, I shall encourage you to check out a few more videos, try a few more questions so you can get used with the process of trigonometric substitution. Good luck.